Okay, so part B, it says the surface area of the end piece is to be painted except for the area inside the hole. Calculate the surface area that is to be painted. And if we look at what's going to be painted exactly, you've got all this cone, the outside of it. It's the surface area of the cone. And of course this end bit here, right? This part here is going to also be painted. The bit that's cut out, the hole, isn't going to be painted because you're not going to see that. Alright, everything you see and once it's hung up, you've got to paint. But we need the surface area of the cone, and I've written the formula up here. Okay, it's not something I remember, right? It's something that's written on page 2 on the formula list, right? It says there curved surface area of cone, right? So the curve, because the curve's round, but ultimately the surface area of this cone is given by this formula pi RL. So of course pi we know, R is the base radius of the cone. Now L is that sort of slant distance there, right? That slant distance. Okay, so that's something we need to consider when it comes to our working out a surface area of the cone. We need to look at how we're going to get this slant distance, because they certainly don't tell us what this is in the question. Okay, here this is our L, isn't it? They do tell us what the height of the cone is, but they don't tell us this. Okay, and perhaps what I'll do, right, is to perhaps make a mock drawing again of this cone, because it looks kind of complicated with this cylinder in there as it is. So I'll draw a cone without the cylinder cut out. Okay, so we'll just try and do a quick sort of sketch here, or a rough sketch of a cone. Okay, now we know the base radius of this cone is 5 centimeters, right? We've established that already. Okay, so to the center there, right, we know that height, or that radius, sorry, is 5. Okay, the other thing we know as well, if you go back to the diagram here, there's our base radius 5, but we also know the height, it's 12, yeah? And I don't have to write the height there. I could actually write the height going through the cone, can't I? So I could draw the height to the peak of the cone there, right? So I know that's 12. Okay. The other thing I know as well is, because this is the base radius and that's the height, okay, when you measure height, it's perpendicular to the ground, to the base. And notice what I've got. I've got myself a right-angled triangle, and I know two sides, so I can use Pythagoras. Of course, Pythagoras says a squared plus b squared equals c squared. Now in this case, this side is my c, isn't it? This is my longest side, opposite the right angle, and I'm going to call it L, because that's what it's called, right, in the formula. So a squared will be 12 squared, b squared then will be 5 squared, equals L squared for c. 12 squared is 144, 5 squared is 25, equals L squared. Add these, you get 169. So we've got to think now, what are we squaring to give 169? Okay, so that will give us L. Of course, what we normally do with Pythagoras, we take the square over and we square root. So what is the square root of 169? If you don't know, just think, what's the square root of 144? It was 12, yeah? 169 is kind of a little bit more, so it's going to be a little bit more than 12, so 13, try. Okay, and you can check, can't you? You could work out 13 times 13 to see if it comes to 169, and it does, right? So L is 13. And then we use then this formula, right, which is on page 2, as I say. So we say then the surface area of cone is pi RL, which is pi times the base radius, which is 5, times the L, which you just worked out to be 13. So then 5 times 13 is 65 pi. So that's going to be the surface area. What we need then is, right, we go back to our original sketch, we've done the surface area. What we need now is this bit here, right? Okay, this bit where you've got two sort of concentric circles, okay, and the middle circle's been cut out. So the technical name is an annulus, okay. But what you do is, to work up that area, of course, you do area of big circle, take away area of little circle or small circle. So you could say, look, shaded area then shaded area of base equals big circle, take away small circle. So big circle is pi r squared, of course. So pi r squared, pi times, and what's the radius of that big circle again? Of course it's 5, isn't it? Yeah. Take away then pi r squared for the small circle, and the small circle is cut out. Cylinder is radius 3. So 25 there, yeah, 5 squared, 25 pi, and that will be 9 pi. So we get 16 pi in total when you take them away. So then the total area will be this 65 pi here, plus then the 16 pi. So we get 81 pi.